Hey, everybody, welcome back once again. Here we are, Wednesday afternoon, maybe evening in some parts of the country, I'm sure. Thanks for taking this time out of your day. I know it's kind of a weird time of day, and a lot of you guys and gals are just really faithful to show up every week, and I appreciate it for one, and I know the rest of the people in the group do too. If you'd like to join us here on the call, it's easy to do. Just go to the Facebook page. I always post the link there. Also in the LinkedIn group, I'm posting the link to get into the Zoom call. You can join us here and just listen, hang out, or ask questions. Be a part of the conversation. And it's always a good time. And especially this evening, we are in for a big treat. We've got Donahue from Frameless Hardware Company. He's going to be talking a little bit about the brand new shower door, frameless shower door manual that just came out. Everybody's excited about it. It's what we're all talking about. And Danny was the guy, I don't know exactly what to call him. He was the chair of the committee, or I don't know exactly what title to give him, but he was the guy who was just leading us through the process and kind of coaching it along, and just awesome being on the team with him for this experience. A lot of people here in the group got to participate in that, and I can say for myself, I'm sure I'm speaking for the rest of the people in the group, is really an honor just to be included in developing something like this that the industry is going to be able to use going forward to just kind of standardize some things and maybe answer a few questions. But anyway, I'm not going to take any more time. It's going to turn it on over to Danny and let him just kind of talk about what he's got prepared for this evening, or what's not prepared. Who knows? Let's
see. Hey, we have no way of knowing.
That's right. So take it away, Danny.
Thank you for that stellar introduction, Chris. A lot of the people on the call, as you said, Chris, did participate in the creation of this manual that we're going to take a look at tonight. So, there were I think 30 people who were listed as contributors to this manual. So there were a lot of people from a lot of different companies, a lot of very respected names. Again, a lot of names that are on people who are on this call right now. So it was truly a group effort, and it was an honor and a pleasure to put it together. And it just turned out, the way we just kept adding and adding and adding, it just turned out, I think, just really, really good. So without further ado, maybe Chris will bring it up, and I'll just start like yapping at you. And if someone has a question or wants to say something, by all means, let's chime in and talk. That's what we're here to do. That's what we did. When we met every other Friday on those meetings, we talked and we worked things out, and because you're all among friends. So, that's what it's all about. So anyway, so there you go. There is the cover of the Frameless Shower Enclosure Design and Installation Manual. We needed a few more words to add to that, but no, I guess those numerous words are good enough. That's the cover of it, and basically, what this document is it takes a frameless shower enclosure from the beginning to end. It takes it from the design phase of just walking in the room. What are you looking for? What are you trying to achieve? It takes it through measuring. Once again, what are the most pertinent measurements? What kind of things are you trying to achieve by measuring the shower, and designing it and all that kind of business? And then the last part is installation. And so tonight we're just going to kind of review just the design part, really. There are some wordy slides here, and I'm not going to necessarily read everything, but there's some good information here. And I think that really this also is a document that is there to help the glazer at large, the person who's on this call right now, because there are people out there doing things that we all know and we all agree are the wrong way to install things, gluing fixed panels into place without any fasteners of any kind. I think all of us would probably agree that's not something we would do, because we value our business and would like to stay in business for a long time. So this document really also can be used to present to anyone asking, whether it's a builder or an end user, or, it could be someone in a hospitality project, what is a safe installation? And if somebody's proposing something unsafe, this thing can back you up, and it can really kind of, show that you're going about it the right way.
Maybe settle some arguments, huh?
What's that?
Maybe settle some arguments.
Yeah, exactly. And God knows we've all been through those arguments when they say, oh, well, Joe down the street's going to do this, Go ahead and zoom big in on that one, Chris.
Right.
Now, this is what the introduction reads. The National Glass Association is proud to present the Frameless Shower Enclosure Design and Installation Manual. Frameless shower hardware has been in North America since the 1980s. And what started out as an opulent design option has steadily developed into shower enclosures found in many millions of homes and commercial buildings. I bet we're all pretty happy about that.
Mm-hmm.
This manual was created to provide guidance and specific best practices for frameless shower enclosures. You can see the way that we're wording it already. We're very neutral in this. We don't go black and white. I don't know that we used always or never in this document, because you have to be somewhat flexible, even though you're giving out guidelines and telling, basically telling people how to do something. You have to be flexible in your language in case things change, as technology and innovation can make things change. So this is meant to educate and assist glass professionals on designing, measuring, and installing safe, functional shower enclosures. The manual also serves you're messing with me now, Chris. The manual also serves as a tool to the professional installer to point out potentially unsafe designs to an end user. So again, it covers the designing, the measuring, and the installation of frameless glass showers. It's not meant to be a complete technical guide, and there's going to be disclaimers that follow this saying that this information was gathered using industry professionals who all donated their time and efforts to contribute and make this document. So that's basically what follows that. You can go to the next slide, Chris.
All right. Here we go.
This is going to be everyone's favorite page.
Yes.
Managing end user expectations for water tightness. The following statements can be used to explain to an end user what can be expected from a frameless shower enclosures. Or from frameless shower enclosures. A frameless shower enclosure is not the same as its framed or semi-frameless counterpart. Minimal use of hardware achieves an all-glass look. This all-glass look does not allow for a kit that is assembled from aluminum extrusions that interlock into one another, preventing water from leaking. An end user must be prepared for these differences and have the expectations that align with this knowledge. A frameless shower is not an aquarium, meaning it will not hold water without any leakage. The amount a frameless shower will leak is dependent on various factors. Primary factor in determining whether a frameless shower will leak or not is the configuration of the shower itself and the type of enclosure being installed. Some showers, by virtue of their design, are not likely to have water escape. For example, very large shower with the door far away from the water sources will be unlikely to leak out of the enclosure. And a shower type on the other side of the spectrum may be, for example, a corner installed enclosure of small proportions, which almost guaranteed to leak.
Mm-hmm.
Most showers fit somewhere between these two extreme examples. Frameless showers are not watertight.
Amen.
Anybody like that? Anybody like the sound of that?
The best thing I ever heard.
And that's just the beginning, baby.
I've been beating this drum for years.
as the people who worked on this document know, there are so many things that are like this that are going to be strewn throughout the document. Let's go to the next page and see what we're seeing for design. And I will explain this too. This guide, this manual is only addresses 3/8 and 1/2 inch glass. It does not address 5/16 and under, not 1/4 inch, not any of the other integrated units. It's truly just for frameless showers, which in the US, which this is the National Glass Association, we're in our nation here, we do 3/8 and 1/2 inch glass. I don't think anybody has any problems with that. So for the purpose of this manual, the process of designing a frameless glass enclosure is converting the design envisioned by the customer into the individual panels of glass and appropriate hardware needed to create a safe glass enclosure. In cases where the customer has an expectation that is physically impossible or renders the end product as unsafe, the glass professional should attempt to arrive at a feasible and safe solution or provide options for redesign. Now, as we all know, getting involved in the design portion is a great benefit when you're called in early like that. But I would also say that probably 90+% of the showers you walk into are already there and you are dealing with whatever it is you are looking at. Would you say that's a pretty good consensus, or do you get called in early in the design phase a lot? Any answers on that?
Not a lot. I mean, from time to time.
Same here. Most of them are already done.
Yeah,
Yeah.
not often, not enough.
Right.
Not enough.
Right. So we're usually faced with what we see. We're usually faced with, what's right in front of you. And we also know that most of the time it's going to kind of declare itself. There's not a ton of crazy options to throw out there so much. A lot of times it looks like exactly what it is. But in those cases when it's not, it's important to talk through all of the different variables and be knowledgeable about what you're talking about, which obviously everyone on this call understands all of that stuff. And it's important to do all of this like before you even start to measure. Make sure you guys know exactly what's going to go where and how before a tape hits the curb. So, all right. So this manual is going to discuss like the best practices, which I think is a great way to say it, as a guide, while recognizing that the glass professional may arrive at the project too late to advise or influence the customer's actions, which is usually the case. So, okay, let's see what the next one says. We'll get to some pictures here. Here we go. This is the beginning of some of these really nice diagrams that are throughout this whole book. So what we're talking about now are the three most common types of adequate substrates. A frameless shower door hinged from a wall is only as sound as the substrate to which it's attached. Trying to fasten a heavy frameless shower door to a wall without proper structural support may result in an unsafe installation. It is important to ensure the wall from which the door will hinge includes adequate substrate. There are several types of adequate substrates. Number one here is a wood stud behind the tile or stone, layered on either masonry mortar or cement board or green board. And you're fastening into a wood stud that's directly behind the bedding material, which is masonry mortar and cement board, green board, and is the best form of structural backing. I mean, everybody likes to be able to tie into a stud, but we know that's not always the case, which leads us to number two.
Here. Number two. Oh, wait, here we go. There we go.
There, perfect. Second one is a minimum of 1 inch of a cement-like material with the correct screw anchors. Now, the tile or stone thickness is counted as a cement-like material because it's a very hard material. The thin set used to attach the tile or stone to the wall is also counted as a cement-like material. And the last component is either a masonry floated wall or a cement board. Green board does not count as a cement-like material because it's basically drywall and different paper.
Right.
So the thickness of the three components must add up to 1 inch thickness. As an example, 3/8 of tile, 1/8 inch thin set, 1/2 inch cement board, 1 inch. And you see the screw anchor that's recommended for use here. It's one of those expanding ones. Everybody in the world has seen those screw anchors. They know what they are. And then the last one are metal studs. They're often used in hospitality applications and can qualify as an adequate substrate. The metal stud should be directly behind the bedding material, and there should not be an airspace between the bedding material and the metal stud. I guess that's kind of repetitive, but it's still true. When fastening to a metal stud, a small pilot hole should be drilled in the metal stud. Then the hinge fastening screw should be drilled through the metal stud, threading into it as it goes through. And I also suggest for the first part of it there, where you've got the tile and the stone and the thin set, is using a green anchor like you saw on the other page in that first bit until you get to the metal stud, and then let the screw thread through that. I think that's just a good safety way to go.
Yeah.
Let's see what's next. Curb pitch guidelines. You're going to like this. One of the simplest and most important factors of a well-designed and executed shower installation is a properly pitched curb. something none of us have anything to do with because we are not called out to the job site until it's done. So, but let's talk about it anyway, because it just became our problem when we walked in that bathroom. Everyone raises a hand and agrees to that.
Yep.
Now, how you deal with that problem, let's take a look at it. So the slope of the curb should be about an 1/8 inch to a 1/4 inch over a 6-inch span, and should be in the direction of the shower drain, of course, to the interior, right? The basic feature of the shower enclosure is the primary means of containing water when combined with the glass enclosure. So if the curb slopes to the outside, away from the drain, no amount of caulking or application of plastic seals is going to prevent the water from getting out. So a perfectly level curb will create an issue with water pooling and eventually spilling out, and a gradual slope is ideal. A slope that's too pitched can have problems with the bottom of the door or the door sweep scraping. Now, I think we got some great little diagrams here about the curb slope. We got the real nice one with the check on it that says that it's got the correct pitch. Everybody's happy, no problems, everything's good. Now, the next one is, just obviously a real problem waiting to happen. No matter what you do on that one, it's sloped out like that. It's just going to go all over the floor. And the third one is honestly a little more common than I'd like to see. And that's just the guy just putting the curb up flat. He's doing his tile and I want to make this square. I'm going to make it flat. He's not thinking to make that inside tile that's underneath, an 1/8 inch or 3/16 shorter so the thing can lean in like it needs to, So now it's flat and water just pools. It just pools. And as soon as you do anything at all, it's going to leak out, no matter what. And then the last one is a really steeply pitched curb. This is the guy who thought he's doing you the big favor. I'm going to go in there and I'm going to make this curb so pitched. Look at that. Ain't no water getting out of that curb. Yeah, the problem is no shower doors getting out of that curb either. So, a threshold underneath, that could do it. Moving it out to the front as far as you can, depending on what the application and the design, you know what I mean? Everyone knows that kind of stuff, but that can be a real problem. So we got the green one and then the 3 red ones don't do.
If a little pitch is good, then a lot of pitch is better.
That's got to be great. Exactly. Exactly. So structural support. I think this is an excellent one, and I'd like to see if anyone feels differently than this. The structural integrity of a glass enclosure is paramount. The glazing professional is normally expected to provide a safe shower environment. Installing an unsafe enclosure proclaiming, quote, the customer signed a waiver so they know it's not installed right, is not usually an acceptable excuse for doing the wrong thing. If anything happens down the line, the waiver can be used against the glazer. Such a waiver might be perceived as an admission of guilt as the glazer holds themselves out as an experienced and knowledgeable professional. And you knew it was wrong and you did it anyway. You had me sign.
Great point.
Waivers,
Great
I don't
point.
dig waivers.
Yeah.
Okay, this is a real nice one. What we'll want to do on this one, tell you what, Chris, can you zoom in on that more toward the top? I'll read it and then we'll look at the diagram on the bottom.
Yeah, I think so. Let me see what I can do here.
Thank you, sir. Oh, one more. There we go. I can read that. Good. When considering a towel bar and a swinging shower door, some planning is required to ensure the door can open without the end of the towel bar colliding with an adjacent wall. This is primarily an issue using wall mount hinges. And I think most people on the phone, if they're being honest, they're probably going to say, or on the computer as well, if you're being honest, you're going to say, you've done this at least once. You put the towel bar too close to the edge, you opened the door, got it about 2/3 open, and it ran into a wall. Hopefully only once, because after that, it's on you. But in some cases, the door can be prevented from fully opening. Like if you're using glass-to-glass hinges, it's usually not an issue. And sometimes pivot hinges, you can move the end of the towel bar in. But when it comes to the worst situation, which is hinging a door off the wall and having a towel bar on that door, there is a way to mathematically make sure you're not going to run into anything. Can you scroll up now, Chris?
Sure.
There's a nice little figure here that's going to kind of tell the whole story for you. So,
Went too far. Okay.
You flew too close to the sun.
Oh man.
Okay, good. I like it right there.
All right.
So I'll start in the top left. To determine if a door can open to a full 90 degrees, several factors must be considered. All figures are based on the location of the hinge pivot pin. So let's take a look at this picture. You got a shower, obviously, and then we got to zoom in on like a wall, and you've got a hinge mounted to that wall. The middle of the pivot point on that hinge is identified as showing pivot point. We see it there.
Mhm.
What you have to take into consideration is the backswing into the shower when you open the handle side out. Generally, that dimension is about 3/4 of an inch on most of your standard hinges. You know, we all know the hinges. So generally, that's going to be about 3/4 of an inch in swing. And then you take the dimension once again from the center of the pivot point, and you measure to the outside of the 90-degree wall that you're opening adjacent to. You take those figures and add them together, and that's going to be the minimum distance from the end of the glass to where the edge of the pole could finish. So it just becomes a math problem. You know, you're just running the numbers and knowing what to measure for. And these dimensions here, I think it visually makes it easier to think about next time you're going to run into that kind of situation.
Nice.
Oh, another great subject. And I see this come up all the time. If 3 side mount hinges are to be fastened to a wall, the pivot points should align with one another. I say must align with one another, but again, we didn't do any like absolutes in either positive or negative. In my mind, I say they must align together. But if they are misaligned, the door may slip over time. I say will slip over time. To check for pivot alignment, view the pivot points of the hinges from 2 different directions, left to right and front to back. So let's talk about that. Left to right, and we're only talking about wall mount hinges right now. We're not talking about glass to glass hinges. We're talking about wall mount hinges. So left to right means, what is your wall doing? That's exactly what it means. If it's a perfectly flat, straight wall, you have no problem. A wall that is not very flat and has undulating tiles or a high point in the tile may present a center hinge that is either drawn inward on the wall, like sucked into the wall, or bulging out or pushing out into the door opening. Now that's going to create a potential alignment problem. When your other hinges above and below are at a plane that's on a different plane than that center hinge, they're going to bind and work against each other, and the door is going to sag. Now then there's the front and back alignment. This has to do with the bow of the glass. If you're going to put 3 hinges on a tempered piece of glass and stand it up in the opening, as we all do it the same way, put the hinges on the glass, stand it up in the opening, get it how you want it to be, mark the wall, and you either drill it then or whatever the case, but you get it where you want the piece of glass to be reveal wise, and you mark it, you drill it, you mount it. Now the problem is, if you have a bowed piece of glass, if you have a piece of glass that's bowed and bulging in the middle, that center hinge may be pushed out into the room further. And so now the pivot points will be misaligned again. So really there's 2 ways you can misalign the pivot points on 3 hinges. Can they be done right? Yes, they can. If you have a perfectly flat wall, that's point number 1. And the other way, if you do have a bowed piece of glass, do what I was saying, stand it up in the opening, get ready to mark all the holes, and you mark the tops and the bottoms, and then you run a straight edge or a straight line or a laser line, and you make the center holes align to that. And if it means bending the glass straight to do it, then that's what you do. You bend the glass straight to make it a straight line.
Gives you a chance to take the bow out of the glass.
Yep.
Yeah.
Yep. Absolutely.
Yeah,
But
using
again,
a center hinge is just a good thing to avoid if possible, right?
I will not use it. I mean, only if it's like, oh, it's a neo angle, because the heaviest duty hinges come, in wall mount and glass to glass. So, inline glass to glass. So if it's a neo angle, now I got to use a third one in the middle. But that is glass to glass, and you're only introduced to one of the bends, in one direction. But it's still not a good thing. I use pivot hinges. That's that point. But
There you go.
okay, let's see what's next. I think we're almost near the end here. Fixed panel attachment. All fixed panels that contact a vertical wall should be fastened mechanically on 2 edges, a horizontal and a vertical, meaning bottom and side, or a horizontal or 2 horizontals, top and bottom. The substrate to which the fixed panels are fastened should be adequate to support the fixed panels. Fixed panels can be attached using U-channel extrusions or clamps. And I think you could say an addendum of or recessed into the stone, but that's pretty advanced stuff, but that is valid. All U-channels should be mechanically fastened to substrates using stainless steel screws. When a screw penetrates the tile or stone, silicone sealant should be used to fill the hole before the screw is fastened. After the U-channel is permanently fastened to the base or wall, the heads of all screws should be fully covered using silicone sealant to prevent water infiltration. Then we know we're going to put silicone in the U-channel, put the glass in, and then run another bead on top of the channel to the glass and from the channel to the stone. So we're really taking many, many, many steps to make sure that water never finds its way down into that hole. And clamps can also be used to capture the fixed panels, and all should be mechanically fastened. It's going to say all the same things there. The only caveat being that if a panel is less than 12 inches wide, only one clamp is required on the bottom. Clamp rules are not, I think, as crazy as they kind of used to be interpreted as. You don't have to go nuts with clamps. Sometimes there's some redundancy, but you should always at least have one clamp on each of the sides.
Good policy.
Now, this is nice too. This has been something that was written in shower door, showers online coding, and in shower door catalogs for a while. And that's doors hinged off of fixed panels. Now it's finally in the NGA document, and it's like official. So any door hinged directly to a fixed panel of glass imposes a load on the fixed panel. And for the door to operate safely, the fixed panel should be held firmly in place. There's several ways to do that. You can put it in, floor to ceiling. You can use a header. You can use support bars sometimes. But when you want to do it header free, there's very specific criteria that should be strictly adhered to complete a safe application. The header free criteria are: fixed panel should be 1/2 inch glass and attached to a vertical wall. Fixed panel should not exceed 22 inches in width or 84 inches in height. The fixed panel should have valid bottom support, mechanically fastened to the curb, U-channel or clamps, like we said, or recess. The fixed panel should use the large heavy-duty wall brackets, 3.5 inches in height, with a 90-degree L shape that fastens to the wall, and there should be the same number of wall brackets as there are hinges. The door cannot exceed 30 inches and can be either 3/8 or 1/2 inch glass. This criteria works for doors hinging from a panel that is in line. That works best. 135 doesn't work quite as good, I think, and is definitely not recommended for 90-degree panels because it'll just pull the panel right over.
Now, I have a question on that. For that hinge panel specs, what's the recommendation, or is there a recommendation for a hinge panel if it's going on a knee wall?
Excellent question. Excellent question. That has come up a lot, and I do want to speak to that. Perfect question. See, these tests were conducted. I was there when the tests were conducted over at the facility at a place where I used to work. These tests were conducted with full-size panels because we wanted to test worst-case scenario, of course. And we found that there was a negligible bow, at these dimensions. So what I tell people is, look, you got a 36-inch tall knee wall. You only have 40 inches of glass above. That is not going to behave the same as an 84-inch tall piece of glass. It isn't. So I think you can go wider on that. Now, the question is, how much wider and at what height? I don't have the answers to that. So you're on your own with that unless we want to talk about it. If you were to say, oh, the thing is, 24 by 40, I'd say, of course, no problem. You say 30, I say, well, that's probably still good. Probably still good. You say it's 60. I'm going, now I'm starting to think, but right. It was tested on full-size panels, and I think that's a very good point to bring up. I'm glad you did.
Okay.
Yeah.
Oh, different types of frameless sliders. We all know frameless sliders are in this business to stay there, in the barn doors and double sliders and everything else. This is just a diagram showing the types of sliders. The top left corner is a double sliding shower door. Then there's a single sliding shower door in the top right. The bottom left is biparting doors. Those don't happen too often, but they do happen. And then the ever ever fun-loving bifolding shower doors, either with or without a header, can be done.
Yay.
Yay. Okay, I think I might have one more or two more slides. What do I have? Oh, this is one of the good ones. I like this one. This is another one of those. Let's see if I can read it. Okay. Anytime there's a change of angle and a change of elevation, there typically is the need to identify exactly how this condition looks. When rendering a drawing that contains a change of angle and elevation, an overhead plan view should be used. I would say must be used. There are numerous possibilities, the most common of which are found in these sketches below. So let's take a look at those sketches. Every one of these things we're looking at here is a true neo-angle. All of the angles are 135 degrees. But and let's assume that the door's in the center and that there are panels on both sides that are on a knee wall. So the one in the top left corner, that's the one we hope for. That's the one we dream for. It's you run into the wall square and you're in perfectly good shape to use glass to glass hinges. You put a 45 miter on the return panel. All is right. We all agree with that. The next one is one where you run into a dividing the angle kind of thing. Both of the miters would be like the 22 and a half on each one. Basically, what does it say? 65 or 67.5 degree, right? So 22 and a half from 90. Miter talk. So that becomes a real pain in the neck. That one's actually the least common one, and it's the hardest one to deal with. Using a panel in line is just almost the only way to do it. Pivot hinges, you can leave a 5/16 gap at the pivot side. That's not good looking. You can overhang the panel a little bit and leave a gap, but it's going to look like crap down below. Now, the last one on the right is probably the second most common one, unfortunately, and that is running into the wall at 45 degrees. Really, there's only one hinge that handles that well, and you're kind of stuck with what you got. But at any rate, I think it's a nice thing to have because it demonstrates the importance of, look, just calling it a 135 is not answering the question. There's more you need to know in order to make sure you do what's right by the sizes. That's it, huh?
Wow.
Hey, Danny.
Wow, indeed, yeah.
Danny,
Yes, sir.
I got a question.
Yes, Tim.
There is a guideline for the PPH 07 for headerless panel. And
It does vary a little. It does vary a little bit.
It says you can use 3/8 up to 12 inches for the panel.
Up to 12 inches. Well, that's what CRL promotes. And I think we might promote that too. That would not at all surprise me. But that was not addressed. That specific hinge type being used in that way is not addressed in the general idea.
Okay.
Yeah, but I agree with those standards. I remember.
You're probably
right. I was, that was tasked to me to write those instructions.
Yeah. The next question is, I see a lot of people using on a pony wall, the glass-to-glass hinge on top and a regular wall-to-glass hinge on the bottom.
Mm-hmm.
The pivot points don't line up.
The pivot points would be dissimilar. You're right. There are pony wall hinges that are designed to be on the bottom.
Yeah.
And they're available in all of the same designs, just people don't think to get them.
But I see a lot of pictures of that.
Yeah.
People doing that. Then they add a second hinge on the pony wall.
Right.
And then the glass hinge on the top. And that really screws it up. Yeah.
Right. And their logic, and it's never quite in the middle either. It's a little offset low. And their logic is, well, I want to use 2 on the wall so I know it's really strong.
Yeah.
Well, you're introducing another pivot point.
And then a lot of guys, they'll just change the cutout of the glass to make it move it closer to the wall.
That doesn't do anything.
Pivot points are still off.
Right. Yeah, the pivot point's still the pivot point. Just because you did a deeper cutout in the glass, you're 100%.
And your boss told me one time that top panel has to hang out 3/16 of an inch for everything to line up.
Who, Jim Audette?
Your
or
boss,
Murphy?
I forget which one it was. He was standing at another booth.
But that's true. I mean, honestly, well, you have to hang it out the thickness of the wall mount plate. Because whatever that thickness is, that is the difference of the pivot points not aligning. Because the center block that's attached to the glass-to-glass hinge is exactly the same as the center block attached to the wall mount hinge. So it stands to reason if your glass is flush with the edge of the hinge, the thickness of that wall plate is what your pivot point difference is.
Yeah,
So when you get the pony wall hinge, that's taken into consideration,
yeah.
and it's made that way so
Yeah.
that the pivot points align.
Mhm.
Every once in a while, the pivot point being off can benefit you, because if the knee wall is out of plumb inward into the opening, an 1/8 inch, now you're tucked under already, so your pivot point aligns, and you're like, oh, okay, cool.
That'll work.
Happy
Yeah.
coincidence. Happy
Yeah.
coincidence. We're
Yeah.
going deep
Appreciate
now. We're
that.
going real deep.
Appreciate that, guys.
Hey, Brad.
Yep. Hey, Danny. So,
Yeah.
no, I just, that's good information. I never even realized that. So, because I've been using regular hinges on the bottom. However, our walls aren't plumb, so we're not always aligned anyway with hinges, but I do get the point.
You know what I've actually seen people do, and I've actually drawn for people myself, is if the wall leans back, let's say it leans back like, 3/8 of an inch. I've actually projected it out, done the math, and seen how much further it would have to continue to stay in a straight line and cut the glass out a square wider, and actually take the fixed panel and cut it back out a square. So it's basically a big long line of out of plumb. You know what I mean? But
Yeah.
it does work because the pivot points are aligned.
Yes, I've done that. Mhm.
That's good stuff, man.
Yeah. Be creative.
That's right. It's the stuff that makes it go around.
Exactly. Well, I see Bill Dobman, and I always think about he those guys use pivot hinges pretty much exclusively. So I don't think we really talked much about using pivot hinges with hinging from fixed panels, because I think you have a little bit more room to work with, when most of the weight is sitting on the bottom hinge.
I completely agree.
Mhm.
Yeah, that's what Tim was saying, and when it comes to using those 07s, those inline pivot hinges, I think you can increase the width of the panel. And I think you can even use 3/8 glass if you're doing the 3/8 pivot, like up to about 12 inches wide. If you're still using those heavy duty brackets, I think it's very steady that way. And you're right. Going wider on the fixed panel would only stand to reason because all the weight's sitting on the floor. It's just a balancing act at that point. It's not pulling on it at all. I think it would be different. If we were to test that, I think we would find very different results that would make it much bigger. Maybe that should be a future thing to do. Set some more standards.
Experiment. Let's experiment.
Yeah, that would have been an addendum. We talked about that. It's just that I didn't think there was enough application that, we had so many other things to put in that book that to go down that rabbit hole opened up a whole bunch of other things.
Yeah, we did talk about rabbit holes.
Yeah.
Sometimes.
You always want to leave a little something on the table too, right?
Yeah.
You want to leave them wanting a little bit more.
And also leave things open for interpretation. If it's not addressed specifically in there, like if somebody were to say, well, wait a second, what about pivot hinges? They bear the weight differently and all that stuff. Those are absolutely valid points of, conversation. So because it's not addressed in there, it basically kind of still leaves it open for the person's, informed interpretation, I guess.
Yeah. Like you were saying too, the whole kind of feeling of the manual is not real like totalitarian kind of like, you must do this, or you're wrong if you do that. It's like, hey, this is really what you should do. This is, it's worded in a way that's not really offensive, to a person who reads it and who might be a little bit more creative. And so it's not, nobody has all the answers, right? But to kind of get everybody kind of on the same page, I think was well worth the effort.
I think that the key word to this whole thing was that it's a guideline, right?
Right.
And you've got a good guideline to go off, and everyone knows that there's a what do you want to say? A factor that you can go over like anything else. It's rated for a certain weight, and you can push it, 5%, 6%. But we also didn't want to come out with a document that some lawyer is going to dig out somewhere and say, hey, even your own safety manual says you must do this. That's the one thing we wanted to stay away from. Because
Exactly.
that's the first thing that happens. Some kind of disaster happens and they're going to go to that manual, or they're going to ask the guy, well, isn't there an industry standard? They pull out this book. It's the last thing you want to do is hang the installer, who many of these guys didn't see the job, didn't lay the job out. They're out there to install it. And we don't want to put them in harm's way. So we use it as a guideline.
What do you think about using glass transom instead of a header? I see a lot of that trend going around, and I use it too myself.
Well,
I like it.
I want to know your thoughts about that, Danny.
I like it a lot. I'm a big proponent of that kind of thing. Anytime I've seen people say, look, I've got this 70-inch wide by 80-inch tall panel that's just a return panel, and there's just a door opening to walk into. And that panel is going to be really flimsy. So I think I want to use a support bar. I'm like, use a transom. Just attach a transom to the walk-through wall, and glass to glass, have a nice day. And they are very sturdy. I think they're very strong. I think it's an excellent idea. Neo angles, absolutely.
Yeah, I've used them in sturdy too, but when you input it into Showers Online, you get a flag, but it lets you still do it, but it gives you a warning. Hey, you need a header, So
Yeah.
It doesn't really understand what you're doing,
no, it's
No.
not.
but it's just a
tool.
computer, they're not really intelligent.
It's something that, as long as you use it to your benefit and you know your business and you're getting what you should be getting out of it, it's the best.
It's sturdy.
It's incredible.
It's sturdy. I mean, I trust it. But I just want to get your thoughts about it. Like I said, I use it, and then you were also talking about you and Tim were talking about the using a glass to glass hinge and then using a wall hinge. And you said there was a different wall hinge for the application. Which one is that one?
It's called,
to me, because I used, let's say I'm doing an inline unit, and let's say I have a knee wall or whatever. I'm gonna use it. I'm using a 180, and I'm using 037 on the bottom. Is that the
Sure.
right? Is that the right application, or is there a different one?
there is a different one. I'm not going to say it's not right because of what we were just talking about. You know your business, you do your business, but it's
always worked, but I'm always up to learning. If I'm not gonna say, I'm not gonna say here with I'm the badass, whatever, but I'm always up to learning new
That's
things.
good.
So it'll make me better in the long run.
I learn from people all the time. I'm totally with you on that. Yeah. The difference is just the thickness of the wall mount plate. I mean, it's just, if everything is perfectly plumb, the difference is the thickness of the wall mount plate that fastens the hinge. So there's something called a pony wall hinge. And what it is the center block has actually been cut down. So you'd think to yourself, well, that means that the hinge is going to run into the plate. Well, no. The mounting plate is only as tall as the center block. So it only has two screws, one screw on the inside, one screw on the outside to mount it. It has a little tiny plate, like only an inch and a quarter tall, and just get the screw on each side. And the center block is shorter. So it takes the body of the hinge and brings it closer to the wall. So now it's in alignment with the glass to glass hinge above it, because the thickness of the wall plate has been eliminated. The center block is shorter and it's closer to the wall. You still have a wall plate, but you just took it up in the center block. That makes sense.
So with the 044s, will they work in that same sense too? With the 180? With the 180?
They would be the same as the 037s. The offset
backing
plate,
plate.
large plate, same. Yeah, it's the difference is in the center block of the hinge. It's a shorter center block, making the whole operation closer to the wall. So yeah, it's a specialized hinge.
Wouldn't an H plate work the same? To do the same?
No,
do the same?
because the pivot point isn't offset the way that this.
Gotcha.
Exactly.
Gotcha.
That's what the whole deal
I
is.
never knew that. See, that's something brand new, huh?
Yeah.
See, that's why we come here every week.
I want to say,
man.
have I been
That.
have I been doing wrong the whole time? But it works, so I don't know. I mean, it's
Not wrong. You could just be doing it a little bit better.
Yeah. There's just a little better way to do it.
And those two screws will hold the door, huh?
Uh-huh.
Yeah.
Really?
Yeah.
Huh. See, I learned something new today.
Yeah, one number 10 screw can actually hold like what, 90 pounds or something?
Well, that's what I do.
You put like eight screws to hold up a door, that's a lot of screws.
Well,
I mean, yeah, it's good.
when I install a door by myself, I get 037. Yeah, and I'll drill in and I'll screw the first screws in outside, and that door is operable. You can open and close it until you go inside, and drill the other ones. I mean, those things are strong.
Yeah, they are. They are.
Huh.
I got ambitious once and made a regular heavy hinge, and I actually took it apart and trimmed off the block and made it shorter and got it to work.
Oh, really?
Yeah.
You actually trim the center block yourself.
But then when you open it, it hits the backing plate.
Right. But the backing plate has to be the same size as the center block. That's
I found that out.
It's like, well, now that I moved the hinge closer, it's going to run into the wall plate now. So yeah, you got to redo that.
Yeah.
I got to rethink what I'm doing now. Thanks, Scott. Thanks a lot, guys.
Hey?
Right on, man. Right on. That's a good.
Another tool in your toolbox, right?
Yeah, I'm right here and see if it stays.
That's right.
And
All
what
right,
happens, Danny,
I know you got questions out there. Who's got questions?
Yeah. So Danny, what happens if you're using a wall mount hinge and it's severely out? I mean, is it like premature failure, clicking? Like, I notice the pivot hinges click sometimes when they're not in alignment.
Yeah, if pivot hinges are not in alignment, they can click, and they can also just you'll just feel it. You'll just it'll be binding kind of, Now, when you say that the wall mount application, are you saying that that the wall's not straight, it's not flat, or are we saying?
So yeah, say your pony wall is kicked in quite a bit or kicked out, and you're using a wall mount hinge, standard hinge, and not the pony wall hinge.
Right. Oh, okay. And then you got the glass-to-glass hinge up above, right? Because you're doing a combination.
Yeah.
Well, that completely depends on which way the wall is leaning. If the top of the wall is leaning into the opening, meaning that the bottom is, kicked out away from your level, then that can maybe even benefit you. Like I was saying earlier, like if that gap is, let's say, 3/16 of an inch, something like that, you using the hinge that has the back plate actually helps you because it shims it out 3/16 to make it in alignment. Yeah, exactly.
Sure.
Now, if it goes the other way, what you got to start doing. So now let's say it's wider opening. So you're pulling your level away at the top. So it's like 3/16 wide, 1/4 inch wide, something like that. If you're going to go glass to glass above, you're going to have to take that fixed panel and extend it and hang it off the edge of the glass, off the edge of the wall till the thing gets to the point where it would be a plumb situation. Otherwise, it's just not going to work correctly.
And then does the wall mount wear out quicker if you don't do that?
Gotcha. I see. So like what's going to happen is it's going to want to start to bind up. It's going to want to start to get loose. The little set screws that hold the body of the hinge onto the pivot pins, you open the door, you got those two little set screws. Those things seem to come to work their way out to where now you get like a looseness there and you get that clicking kind of noise that you'll start to get. It doesn't have to work its way out much to make it click. The way to get rid of that clicking, a lot of times, open it to 90 and tighten those set screws, make sure that they're seated correctly in there, and then tighten them down. A lot of times I'll get rid of clicking, but let's say it's just in a bad bind. What's going to happen? Well, it's going to wear irregular from the inside out. You've got stainless steel going through a very thin brass little sheath there. And if you're out of alignment, it's going to irregularly wear. And at some point you'll have a failure. Who knows when?
Danny, thank you for that. 'Cause I've been doing this for a while. I've never thought about that. And every knee wall situation is always out. Very rarely are they plumb.
Isn't that
I always use a wall mount hinge. I've always wondered what a pony wall hinge was.
Oh, there you go. Yeah, that's the purpose.
That's awesome. Thank you.
Cool, man. Cool. Good deal.
We were talking about using pivot hinges, and so I just looked up an order I did more than a year ago, and I called you, Danny, to get your opinion on whether it would work or not. And it was a Senior Prima glass to glass, and I did a 12-inch, half-inch glass panel. And this is a big door. I mean, it's pretty tall. In fact, I'm not sure what the height was. I forgot to look just now. It was pretty tall, probably 84 inches. And the door was 36 wide. And you had the confidence it would handle it, and it sure did.
Oh, wow.
Yeah.
Yeah. I do remember that because you're hinging off another panel, but you're using pivot hinges. So it's exactly what we were just talking about, like maybe 10 minutes ago. And here you have a real life example. So that was a 1/2 inch door that was 36 inches wide.
Yeah, I'm going to look at it right now. I can't see it.
Wow.
Look at this. It was, yeah, it was 85 inches tall.
Oh, Brad, you shouldn't have done that.
Glass on the, I did 3/8 glass on the door though.
Oh, on the door. Okay, good.
Yeah. But I did use the senior Primus.
Right. So you used the extra gasket.
Yeah.
Yeah. There you go. Good. Right on, man. See, there you go. That's real life. That's something that Brad did, and it worked for him. So we talked about this, and he did it, and everything's good. Glad to hear it.
I
They
like
live happily ever after.
Sometimes when
Exactly.
you have a real big door, I do use the senior Prima or, one of the big ones.
Yeah.
Mhm.
And I had actually, related to my question earlier, I took a look, and I did a 1/2 inch panel on a knee wall. I don't know, it was maybe 4 months ago, and I checked the dimensions on it, and it was 45 1/8 by 42. And I used the glass to glass pivot hinges up top, and I had no flex on the panel. I had anticipated a little bit of flex, and my solution was going to be to take the springs out of the top pivot to kind of take a little tension off. But it wasn't necessary. It worked out fine, and so
Hey,
I don't know. Again, I don't know what the recommendation is, but that worked, and I haven't gotten a call back or anything. So
that's really good to hear, because that gives us again a little more information. Hey, it was like 42 by 42, something like that. And with pivot hinges, the thing where that's a great thing to hear. Hey, another thing you can do if you don't want to make the top hinge passive in that way, you can actually just take the thing out and turn it a quarter turn and then put it back in. So now one hinge will now self-center in the out position at 90 degrees. So you open the door to 90, it falls into place. And so you're using one to close and one to stay open at 90.
Wow, that's a great idea.
Yeah, I've done that where I've run into some.
Wow, that's pretty cool.
wow. Okay. Thanks for that.
Right on,
And
man.
you just blew my mind.
One thing I've done is use the adjustable hinge because the tension isn't so strong.
That's true.
Now, that brings up another question. Is the pivot point on that a little different than the other hinges?
It's the same. The pivot point's the same on that one. Because they use the same center block, they drill it out differently. They machine it differently. So yeah, the pivot point is the same on that.
Okay.
Mm-hmm.
All right.
Hey, are you guys going to come out with the by any chance any glass to glass neo angle for a velour or the Pasadena?
I didn't hear that question. I'm sorry, it broke up a bit.
Adrian, we're losing you.
Adrian, just
Are you losing me? Hold on.
Stand on one foot. Stand on one foot.
Can you guys hear me now?
Yeah.
No?
Good, man.
Are you guys on the velour and the Pasadena? Are you guys going to come out with a 135 hinge by any chance?
Ooh. First of all, appreciate the use of my part numbers. And my wow, that just is almost unprecedented. I really appreciate it. I can't tell you how many Geneva and Vienna. Hey, don't get me wrong. I was Geneva and Vienna for 23 years, but I'm not. Thank you. That's actually a really good question. You know what? That hasn't been developed, and boy, isn't that a really good reason to do that? Because it hasn't been developed. Why not make a neo angle hinge out of that? I think that's an excellent idea.
Mm-hmm.
Yeah, because I use the Pasadena and velour quite often. I use them quite a bit.
a lot of people are taken to the big one, you know? They're
Yeah.
just like, I don't have to think about it. I don't have to think, am I close? Am I not close? I'm just going to use this thing, you know?
Well, I use it. I use it regardless if it's half inch. If it's a half-inch door, I automatically use them. I just feel like they're the sturdiness of them is just, I feel more safe.
Yeah,
Put those on.
it's a different hinge. I mean, even that inside cover plate, it's got that big, I-beam support running right down the middle of it.
Oh yeah,
They're
for sure.
locks, and you're just like, wow, that's not something any other hinges have. Those real heavy duty ones are great. I think they're great.
Yeah,
I love them. I love those. I use them a lot.
it's
Yeah.
better than having
Yep.
better than having the third hinge in the middle, right?
Oh,
yeah,
man.
way better. Way
Don't
better.
get started.
Yep, no doubt.
Too funny. Too funny, man.
Got a few minutes left, about 3 minutes. I know somebody's dying to ask a question.
Hey, I got a question.
I knew it.
Cool.
So going back to that top pivot, glass to glass, Bill, what's the widest panel you guys use with that? And obviously in a 1/2 inch. But I've been getting some neo angles and they don't want headers. So I thought maybe Danny could probably answer this question too, but Bill uses those pivots most often. How do you do a large, like a 28 return on a neo with a 28 door with those 07 hinges, glass to glass pivots?
Well, I guess the answer to that question is if you're going to exceed what the recommended width is on the return panel, you have to ask yourself, how much deflection am I going to get out of this? Once again, when you're using pivot hinges, top hinge is relegated to a balancing act. It's just there to balance the door. When you're opening and closing the door, it doesn't shift. It doesn't seem to move, obviously, the way a side mount one will. When you open the door, everything moves all in one direction. You don't get as much out of that. So what dimensions are we talking about? Like 28, 28, 28, something like that? Or
Yep. Yeah, especially like on a neo angle.
Yeah, sure. I mean, there are a couple of companies that have glass to glass hinges like that. And if you're using a 1/2 inch return panel, probably using those heavy duty clamps that we talk about, I think that seems reasonable. Yeah. And I'd be curious to hear how your results are, because I think that does sound reasonable. Pivot hinge is a whole different thing, man. Whole different thing.
Or suggest a glass header. I would suggest that instead of having a
Absolutely. You could use the 4-inch tall header and just use side mount hinges and have a nice day. Absolutely.
Yeah, and I costed that out, and it's about the same price either way. A little bit more with the transom, I think. And she just really didn't want anything on the top and wanted it real clean. And I ran out of options without using a header, and I just felt more comfortable using a header with a pivot but I know Bill does that a lot with those. So I was just kind of wondering what he would do on that situation. How big of a panel have you hinged the door off of with those 07s, glass to glass pivots?
Yeah, panel going all the way to the floor. You're talking about on knee walls?
No, just a panel, same size as the door, not to the ceiling, panel to the wall.
Oh, yeah. Like Danny said, as long as you're using those heavy duty clamps on the side, we've pushed it up to 30. We've done 36s on the panel and go up to 30 on the door.
Wow.
Oh, wow. Nice. And that's on a neo angle shape, right, Bill? Neo angle shape?
Yeah, we got a 135 bracket for it. Yeah.
Right. Absolutely.
Now,
yeah. Got it as well. Yeah.
If it goes into a custom angle, that changes things because we don't have that fixed bracket set up there.
Right.
And the adjustable brackets, I don't like the strength of them. But with the fixed 135, we've done that. And I use 1/2 inch on door and panel. I don't mix. I don't put the 3/8 in the door. We still use 1/2 inch doors.
And you went up to 36 inches wide.
36, yeah.
Wow. That's in not minimal amount of deflection. Like barely.
Not enough to cause a problem. No. I mean, we'll test it, but again, if you're using those heavy duty wall brackets as opposed to channel or even embedding it, they add so much more stability. So much more.
Yeah.
That's good to hear. It's all good news. All good
Yeah, awesome. Hey,
Here we
We're
are.
out of time.
Wow. did that
I mean, I
fly
feel
by?
like we're just kind of like
Awesome.
are scratching the surface here. You know, Danny, we talked a little bit. I mentioned the idea of maybe doing more than 1 week. I mean, I hate to impose on you. I mean, it's probably your dinner time and stuff like that.
I'll be eating when I'm done. You're right.
So, I mean, would you like to come back again next week? I mean, I know we just like covered a few pages of the manual.
Well, in case you haven't noticed, I truly have enthusiasm in talking about the things that we're talking about. I love this shit. You know what I mean? This is what I do. And and I just love talking, and I love hearing what people say and people's opinions about how they do things. You know, the answer to you is I'm on, man.
All right, awesome.
Totally.
And then, because I know that once this video goes out and people see it and people hear the podcast and stuff, they're gonna be like, oh man, I wish I was there. And I wish I could ask Danny this. And so they'll give them a week to think about that and brew on
That's
it.
cool.
All right. Cool,
do it.
man. Well, let's plan on doing that.
All right. Sounds good.
Danny, thank you so much. It was awesome.
No doubt.
Thanks,
Hey,
man.
You guys have a
Appreciate it.
good night.
Thanks, Danny.
Yeah,
All
good
right.
job.
Yeah, thanks.
Wow, man. I look forward to seeing everybody again, man.
Good night.
Likewise.
Thanks, Dave.
All right, you guys. See you next
Appreciate it.
week.